Okay, so we're looking at the basics of atomic structure. Let's remember that we have two numbers that we want to be paying attention to for each element. Those are the atomic number and the atomic mass. You see them here. Atomic number is the number of protons in the nucleus, and it determines the identity of the element. The atomic mass is the sum of protons and neutrons. So if we're looking at this particular sample of helium, it has an atomic number of 2. You can see that it has 2 protons here in the nucleus, and that determines why its atomic number is 2. But it also has an additional 2 neutrons here and here, and that means that it has an atomic mass of 4. 2 neutrons, 2 protons. All right, we've got 2 systems for indicating these properties of a particular element. This is called nuclear symbol notation. We put the atomic number on the bottom, we put the atomic mass on the top, and we'll indicate any charge an atom might have with a superscript. For charge +1 or +2 means it has lost 1 or 2 electrons. If it has a charge of -1 or -2, it's gained an appropriate number of electrons. And if we're dealing with hyphen notation, we're simply going to indicate the name of the element followed by its atomic mass. So let's try a couple of these and see how they work. In number 1, it's asking how many neutrons are in an atom of oxygen 18. We know that oxygen has to have 8 protons. We know this because we can see it right here in the periodic table. Let me get there. I apologize. Here we see oxygen's atomic number is 8. So we know it has to have 8 protons. This hyphen notation tells us that it has an atomic mass of 18. Well, if the total of the sum of protons and neutrons is 18, and there are 8 protons, by default, it has to have 10 neutrons. And that's how we do that one. Here is number 2, right, the nuclear symbol for carbon-13. Carbon-13 is a sample of carbon with an atomic mass of 13. So we'll put the atomic mass up here as the convention for nuclear symbol notation dictates. It's carbon, and so it has to have an atomic number of 6. We see that here. That carbon has an atomic number of 6. That means 6 protons. And so we'll simply indicate that it has an atomic number of 6, and we'll write that down here. There's the nuclear symbol for carbon-13. This problem does not specify charge, so we're not going to indicate anything to the upper right of our nuclear symbol. Here we have the atomic symbol for an isotope of a mystery element X. What we know about this particular mystery element is that its nuclear symbol notation indicates that it has an atomic number of 17. So there's really only one, get rid of that, only one element with an atomic number of 17. It has to be chlorine. That's the only element we know of that has an atomic number of 17. And so what this is asking is to identify this element and write its hyphen notation. Well, it has to have 17 protons, and that makes it chlorine. And according to this particular specimen, it has an atomic mass of 37. So we'll indicate it here in hyphen notation. Let's make that look more like a 7. There we go. Number 4 is asking us to write the hyphen notation for the element whose atoms have 35 protons, 46 neutrons, and 35 electrons. Right off the bat, it's telling us we have an atomic number of 35. There's only one element on the periodic table with an atomic number of 35. And we see that here, that is bromine. So it's asking for the hyphen notation. Whoops. We know that this is bromine. And it has to have an atomic mass of 35 plus 46. And so if we add 35 and 46, we get 81. There is our atomic mass. All right. Here we have number 5, and it is asking how many protons and neutrons are contained in each nucleus. And it's also asking if each of these elements is uncharged, how many electrons are there. That's what we call an ion if the element is charged, but these are not. That tells us that because these ions are uncharged, their numbers of electrons and protons must be equal. So this particular sample has an atomic number of 26. That means it has to have 26 protons. It's got an atomic mass of 57. And that means that we need to subtract the protons from the atomic mass to get the number of neutrons, and we get 31. Oops. That means this particular sample of iron has 31 neutrons. And because it's a neutral atom, the number of protons and electrons must be identical, 26 electrons. Here is lead, our next example. This particular sample of lead has an atomic mass of 82, atomic number, of 82, and that means it has to have 82 protons. Because it has an atomic mass of 208, we must subtract the number of protons from the atomic mass to get the number of neutrons, and this particular sample has 126 neutrons. Because it's a neutral atom, it has the exact same number of electrons as protons, and that means that it has 82 electrons. Finally, we have a sample of calcium. This particular example has an atomic number of 37. That means it has to have 37 protons. Because this sample has an atomic mass of 86, we're simply going to subtract the number of protons from the atomic mass to tell us the number of neutrons, and this is 49. And again, because the number of protons and neutrons is identical, number of protons and electrons is identical because it is an uncharged atom, it has to have 37 electrons. All right, last one. For each of the following ions indicate the number of protons and electrons. It doesn't say anything about neutrons, so we're not going to worry about that. Let's go to our periodic table. We're going to find the atomic number for barium. That tells us how many protons it has. Barium's way over here. It's in group 2, near the bottom. And here we see that it has 56 protons. So this is barium with 56 protons. It tells us that it has a charge of 2+. That means somewhere along the way it has lost 2 electrons. If it was an uncharged atom, the number of protons and electrons would be equal, and therefore it would have 56 electrons. But it has lost 2 because it has a net charge of +2. That means it has 2 more protons than electrons. So it has to have lost 2 of its electrons. We'll call that 54. Here is nitrogen. We're going to look up nitrogen's atomic number on the periodic table. We'll see it here. It is in group 15, and it has 7 protons, so we'll list that here. Nitrogen has 7 protons. This notation is telling us that it has gained a charge of -3. That means it originally had 7 protons, but now it has acquired 3 extra. 7 protons, it has acquired 3 extra electrons, because that makes the overall charge -3. Therefore, the number of electrons must be equal to 10. Here is cobalt. Cobalt is a metal. It's near the middle of the periodic table. We see it here. It has an atomic number of 27. And so we'll just say that this particular sample of cobalt has 27 protons. This particular sample of cobalt has a charge of +3. That means it has lost 3 of its electrons. They were originally equal to the number of protons, 27, but because it now has 3 more protons than electrons, it has to have lost 3 of its electrons, and we'll call that 24. Finally, here is bromine. Let's look up bromine on our periodic table. It is here. Bromine has a charge of an atomic number of 35. That means it has to have 35 protons. And because this particular sample is indicating that it has a net charge of -1, it must have 1 more electron than it does protons, because otherwise it would have no charge. Well, if it has 35 protons, it has to have 36 electrons. And that's all you do.